Accelerated Algebra 2, stir up here. This is going to be number 9. So again, there's multiple videos this week, but they're all a little bit shorter. They should all have the notes that go along with it blank and filled out, and there'll be a quiz at the end of the week. All right, oops, went too many pages. Okay, so let me get rid of that. Condense the logarithm, so it's a single log. So first thing, we don't have anything out front, so when we're adding it, it'll just become log. And I'm going to put this in parentheses. It's just nice to keep them grouped so you know that it's log 3x. It's not necessarily incorrect if you have it like this. It just looks a little nicer when you have it in parentheses. Letter B, this exponent comes up here. We're adding it, so we'll multiply. So this becomes log x squared 4, which those are being multiplied. That's kind of a goofy order, so you want the number to go first. And you just get 4x squared, and that's all done. And again, notice it's grouped in parentheses. Down here, I'm going to bring this up, and nothing to bring up, but I'm subtracting. So I know that I have log base 5, and I have x squared, and the whole thing will be over 3. The reason it's over 3 is because there was a subtraction sign here. I just want to bring this up here, and we get 7. So we get natural log of x to the 3rd times 7. Again, that's kind of goofy order, so reorder it, having the number first. And again, notice I have it in parentheses. All right, rewrite an exponent form and then solve for x. Okay, so remember our shell. As long as we have log, base, whatever over here, I'm going to shell it around. So this becomes 3 raised to the 5th power equals x plus 4. And 3 to the 5th power, I don't have that on top of my head, so I have to hit my calculator real quick. Hope you're all doing well. We get 243, is that right? Yeah, 243 equals x plus 8. Subtract 8 from both sides. So I find that x is equal to 235, if I did my math right. These are ones that you want to make sure there's not something called an extraneous solution. If I took this 235 and I plugged it back in here, it didn't give me a negative number, so we're fine. All right, so next problem, we have ln x plus 7. So let's just move the 7 over first, and then we're going to deal with the ln x here in a second. So I get that first. I think most of you would be okay from that point. Remember that log base e of x is equal to natural log x. So I'm going to replace ln with log base e. And then if I do my snail around, oops, I wanted that to be green. Come around like that. So I get e to the 19th is equal to x, and e to the 19th is going to be an extraordinarily big number. Let's take a look, see if we can get that clear. It's comes up to like 178,482, 300.9 roughly. So I'd say just leave it as e to the 19th. No reason to try and go with big numbers. All right, so this problem, remember if we have the log by itself, it's to base 10. Okay, so I'm going to go 10 to the 2nd is equal to x minus 5. Well, 10 to the 2nd is 100 equals x minus 5. So if I add 5 to both sides, I get x equals 105. And again, it didn't give me a log. If I plugged 105 back in, it didn't make that a negative number, so it works. On this one, we can go ahead and kind of do tug of war with it. One thing that we want to know just from this one is we know that x can't equal 0. So as long as that doesn't happen in our answer, we're fine. But I'm going to go ahead and reduce this first. So I get log 5 to the x equals 2. And remember, if it's log by itself, it's going to be 10. So I'm going to go 10 to the 2nd is equal to 5x. So that's 100 equals 5x. So x has to be equal to 20. And again, if I plug 20 back in here, I wouldn't get a negative log, so that's perfectly fine. All right, now we want to solve these. Well, the nice thing is if I have like bases, I'm just going to set the exponents equal to each other and solve it. Minus 1. So subtract 2x from both sides, so I get 2x over here. and then that was a -1, right? So I'm going to add 1 over here, so I get 4. So I get x is equal to 2. We don't have to really worry about positive and negatives when we're dealing with just an exponent. Again, bases are the same, so I'm going to get 3x is equal to x plus 5, or excuse me, x plus 8. Subtract x from both sides, so I get 2x is equal to 8. So x is equal to 4, and that answer's fine. For problem number 3, we want to extend this a little bit. So we want to think about, is 4 the same thing as 2 squared? And the answer is yes. So this side I get this, but then this side I'm going to get this. We replaced 4 and made it 2 squared. Remember, you're going to multiply the exponents. So then I'm going to set the exponents equal to each other. So I get 3x is equal to 2x minus 2. Realize I distributed over the 2. Subtract 2x from both sides, so I'd wind up with x equals -2. We don't have to worry about the negative exponents up here because I can have a negative exponent. It's not called an extraneous solution in this case. On this one, we want to make it to be base 10, so I have to realize that 0.1 is the same thing as 1 over 10. 1 over 10 is the same thing as 10 to the -1. So I get 10 to the 3x minus 4 is equal to 10 to the -1. Let's go ahead and set the exponents equal to each other and solve. So I'm going to add 4 to both sides, so I get to a 3. Divide each side by 3, so I get to a 1. And again, we're not dealing with log or natural log, so we don't have to worry about testing to see if the answers work. Okay, so what can we do if we don't have like bases equal? Okay, so let's work through this. So let's just subtract 3 from both sides first. And I really am not going to be able to make 10 and 5 the same base. I realize they're roots of each other. That's fine. So what we want to do is we can just go ahead and rotate this around with our shell. So I'm going to get 10 raised to the 5th power is equal to 2x. Well, 10 to the 5th is 10 to the 1st, 2nd, 3rd, 4th, 5th equals 2x. So that's 100,000. Divide each side by 2. So I get x equals 50,000 for an answer. All right, problem number 6, we're going to go ahead and subtract 4 from both sides. So I get 10x equals 2x minus 3 is equal to 17. I need to convert this into a logarithm. So I'm going to start at the base and work my way around. So I get log base 10, which is just the same thing as log. 17 equals 2x minus 3. And then on your calculator, you can do log of 17. Okay, remember log of 17 is going to be nice. So let's see, we're going to do, oops, 17. So log of 17 is roughly 1.23 equals 2x minus 3. I'm going to subtract 3 from both sides. That's going to give me 2x is equal to negative 1.77, and I'm rounding it, so we're okay. And then we'll divide that by 2. And so I'm going to find that x is equal to negative 0.88 to 2 decimal places. And again, if you took that and plugged it back in here, it's going to be fine. You can have a negative as an exponent. You just don't want to have a negative with a log or a natural log. Okay, yes, I understand we converted it, but it worked on the train. All right, so now we want to take natural logs. So the reason we're using natural logs is we have e. So I'm going to subtract 9 from both sides first. So I get -4 equals -4 e to the x. Divide each side by -4 to get the e to the x by itself. So that gives me 1. So I have e to the x is equal to 1. Now you should be able to do that. You should be able to realize that x has to equal 0 because e to the 0 power is 1, and that's our answer. All right, so check to see if the x value is a solution. Okay, so we're going to see if I plug this in here, if I plug it in here, do I get the correct thing? So is natural log of 2 times e to the 8th equal to 8? Well, we can expand this, so I get natural log of 2 plus natural log of e to the 8 equals 8. Natural log of 2, I'm not sure what that is, but I'm not going to worry about it. I know natural log of e to the 8 is 8. So is natural log of 2 added to 8 the same thing as 8? And no, it's not a solution because it's not the same thing on the both sides. We want to see if 125 works. So if I plug 125 in here, I get log base 5 of 3 times 125 is equal to 6. 3 times 125 is 3 times 125, that's going to be 375, I believe. Is that equal to 6? And then if you can't see that right away, you can say this. Is 5 to the 6th power 375? Well, 5 times 5 is 25, times another 5 is 125, times another 5 is 625. So this is not a solution. All right, for this problem, I'm going to take this, I want to plug it in for x. So I get natural log of 6, and then e to the 4th over 6. We want to know if that's equal to 4. Well, the nice thing is that 6 and that 6 cancel, so I get natural log e to the 4. Well, natural log and e cancel each other out, so I wind up getting 4 equals 4, so that definitely checks. Sometimes you need to use the property of logarithms and then check the exponentiate of both sides of the equation. Check for extraneous solutions. Extraneous solutions is where I would get log of a negative value on these ones. So we need to take our answers, plug it into the original, see if log becomes negative. So I'm going to go ahead and condense this. So I'm going to get log 5x and x minus 1 equals 2. And this is log base 10, so I'm going to go 10 raised to the and 10 raised to the. Those cancel. So I get 5x squared minus 5x, because I distributed over, equals 10 to the second, which is 100. I can divide everything by 5. And then let's move the 20 over. And we have to remember how to factor. So I'm going to get x minus 5 and x plus 4. And so that means that I get an answer of x equals positive 5 and x equals negative 4. Do either of those answers make any of the logs above negative? And it would here. So the negative 4 is not going to work, but this 5 is going to work just fine. So there's our answer. The other one is called an extraneous solution. We don't count it. Okay, we're going to add here. We're going to condense those back together. So I get log base 3 of x squared minus 2x. And that's equal to 1. We want to get rid of that base 3, so I can do it one of two ways. I can shell around, or I can just go 3 raised to that and 3 raised to them. Those cancel. So I get x squared minus 2x is equal to 3. Subtract the 3 from both sides. And factor it. So I get x minus 3 and x plus 1. If I solve it, and those are both equal to 0, so if I set those equal to 0, I get positive 3 and I get negative 1. Do either of those give me a log of a negative up top? And this one does, so that's not the solution. This one works. All right, so we're subtracting it, so that means I'm going to have log x over 3 equals 1. Remember, that's base 10, and I'll do this one as a shell rather than raising both sides. So I get 10 to the first is equal to x over 3. 10 to the first is 10, so x is equal to 30. If I plug 30 back in, do I get a negative log? And the answer is no, so that answer works fine. This one I'm going to go ahead and condense it together. So log base 2 of x plus 6 is equal to 4. So I'm going to get 2 to the 4th equals that. And I'll distribute that over right now. So I get x squared plus 6x. 2 to the 4th is 2, 4, 8, 16. And let's set it equal to 0. So I have the 0 on the left side, which is fine. The answer will still work. So that's going to factor to x plus 8 and x minus 2, which means that x equals negative 8 and x equals 2. Do either of those answers make log negative? Yeah, if I plug it in there or in there, I'm going to get negative, so that one won't work. The 2 is going to work just fine. And that's it, and there should be an assignment with this. So again, we can set up a Zoom if you'd like. Give me a call, send me a text, let me know who you are and what class you're in. Doesn't matter what period, but Algebra 2, and we can set it up. So 720-273 8859 is my cell number. Happy to help you with this. Okay, have a great day, everybody.